सो हाय हेलो मेरा बच्चा लोग, कैसे हैं सब? हाँ, जल्दी फटाफट बोल दीजिए हाउ यू आर फीलिंग, हाउ मच एनर्जी यू ऑल हैव फॉर दिस सेशन, हाउ मच एक्साइटेड you all are. Everything in the chat box, I'm going to look into it, and I am going to say hi to everyone who's super active here in this classroom. Hi Suti, hi Anisha Korean, बिल्कुल सुगम तन्याना Anisha. Good evening Vishali, then Fairy. Sudhi, yes, I'm doing so good. Thank you so much for asking, Prateek. So, a big hi to everyone in the classroom, right? I know that what we are going to, you all are thinking, what you all are thinking, right? Which means what we are going to do in this particular session, right? So, here we are going to do the part 2 or the very last part of the chapter, Magnetism and Matter. A very small part is left out that we'll be covering in today's class, okay? And at the end, what we have, yes, that amazing, that super wonderful part of this particular session, which is Menti quiz. So we are going to wind up this particular session with Menti. Okay? So this is how the session is going to be. So I hope you all are excited. Anyone seeing me for the very first time and who is thinking, ye kaun hai? So yes, this is Ameer, your physics educator at Unacademy, and those who love me more used to call me Ameer Bhaiya. Then bacha log hai na, a small introduction about myself. I hope you all can see. I have an experience of more than 3.5 years in the field of teaching JEE, NEET, and board student. I'm a BTech graduate from NIT Calicut in mechanical engineering. And yes, I'm from Kerala, Vachalo. So as I'm from Kerala, मुझे हिंदी तो उतना नहीं पता है, which means I'm not so good with the language of Hindi. Obviously, I'll be explaining everything in English only, but in the meanwhile, छोटू छोटू हिंदी भी use करेगा, ठीक है? So this is the entire session is going to be. I hope you all are excited. Bacha look, can you all do a small thing, a small favor to me and to all your friends? Can you share this particular session and tell them that the session has already started and we are going to discuss a lot many things from the chapter of magnetism and matter and understand in a better way. Can you all do that? हाँ, जल्दी फटाफट देख ले. Okay, so this is our schedule for this particular week. Here we are on 16th November with part 2 of Magnetism and Matter. So from tomorrow onwards, we'll be having the session, the crash course itself, but a small change will be there. We'll be only discussing only the formulas and MCQ, but MCQ in the form of Menti quiz, right? Which means the formula, then multiple choice question. Matlab, we'll be having mega Menti quiz in tomorrow's class. Okay? Then on 18th of November, which is Thursday, we are having super mega Menti quiz. Matlab, the entire chapter, which means all the chapters that is going to come for term 1, we are going to make a Menti quiz from that particular, all the chapters. Okay? So this happens on this Thursday, and Friday we have the sample paper discussion and analysis part 2. Okay? So I hope you all are excited for all the sessions that is going to happen in this week. है ना चलो ठीक है now बोल ले, don't you have amazing teachers or favorite teachers in an academy class 11th and 12th? So obviously if you have favorite teachers, you don't want to miss any of their live classes, isn't it? So if you don't want to miss their live classes, you should be getting the notifications and alerts on time. This happens only in the Telegram channel because all the activities, whatever happens in the YouTube channel is being updated in the Telegram. So the link is given here and also in the description box. You can click on the link and be a part of it. Bugs bounty क्या होता है बच्चा लोग? It's an amazing way or a program which is designed for you so that you can get so many prizes. क्या करना है? You just need to go to the description. There you'll find a form. Fill the form if you're finding any inappropriate content which is uploaded by Unacademy, right? So if you find it, if it is valid, prizes आ जाएगा आप लोगों का घर. बिल्कुल. This is true. ठीक है. Emerge program. How many of you know what is Emerge program? Emerge program is help every Unacademy and every students to grab that 35 out of 35 for the upcoming CBSE term 1 examination. Because you all know that the term 1 examination is going to be according to the new examination pattern with multiple choice question, assertion, recent type, and case study. So for getting full marks, you should be having enough practice. So Emerge program is actually weekly multiple choice mock test program that will be happening for 1.5 hours, right? However the exam happens, in the same way mock test papers are given to you in every week. Okay, and let me tell you, these are the subjects. Okay, these are the days in which it happens. Every week it happens. Okay, and let me tell you, it is completely free, bacha log. It's completely free for enrolling into this Emerge program. You don't have to pay anything. You don't want to be a subscriber. You just can come and log in. Don't forget to use this code while you make the subscription. That's all. The code is AMB10. Use this and get into this Emerge program for free. Okay. So I think, बच्चा लोग, you all have shared the class to all your friends. Okay. Now we'll give 2 more minutes for all your friends to join. In the meanwhile, whoever is new here in the classroom, I'll just give a brief introduction about this Unacademy Plus subscription. Okay. In the Unacademy subscription, what is so much important? Because in Unacademy Plus subscription platform, we all educators will be teaching you with a proper schedule in a proper order, so that you can keep track of everything and you can learn everything in a very simple manner. So obviously, you know that everything becomes so simple, your marks will be having a very good progress here. Then top educators of the country who's already having a very good experience will be there to teach you. So they'll be telling you the kind of examination pattern. They'll be telling you what all multiple choice questions you should be practicing so that you'll end up in the colleges you are dreaming about. Then study materials will be given to you. Practice tests and live test series will make you super confident and will bring out the best from every one of you. I think as we are at the academic end, 6 month subscription is more than enough. So it will cost you 1,667. And again, you should know that you don't have to pay that much, because while you use a referral code of AMB10, you get a 10% of discount from the above mentioned price and as many offers as possible. Okay? So for getting offers, don't forget this code AMB10. Last thing, iconic subscription. Because an iconic subscription, you will be given a personal mentor, someone to help you with your academic activities 24/7. Live doubt solving classes will be there. Weekly reports will be given to you for all these amazing features. If you're going for 6 months, it will cost you 2,833 per month. And those who love 10% of discount, क्या कर सकता है? Use कर ले code AMB10. Okay. Okay, that's amazing. So you don't have to think that everything is paid here, because tomorrow we have a special class completely free, right? And here we are going to make a complete chapter MCQ series in the form of quiz. So it happens in an Academy platform. Don't forget to enroll for it. And while you enroll, for enrolling it for free, the code is AMB10. Use the code AMB10, enroll for this particular special class, which is going to happen tomorrow, 4:30 p.m. with me. Right? So complete chapter MCQ revision is what we are doing. Okay? Yes? So that's it. It's time for our studies, which are now. No one is going to stand between us. We are completely going to learn physics. Okay? Or kuch nahi, it's just physics. Ameer Bhaiya and all my bacha log. Hi Mara, good evening, good evening, good evening. Sudeep, so what do you all say? Shall we get started? Shall we all get started? Bol de. Ready with full josh, Anjana? Very good, amazing. Others, I can't see that energy from other people. Okay. Jan Bandhu. Okay, good to have you here, Sana. Okay, yes. Menti will be at the end. Almost by 11:10, we'll be starting the Menti. Menti will be at 11:10 p.m. Okay? Ready? Okay, here we go. Let's start with a smile. Hana? Very good, very good, very good. So, we are going to start by learning some of the terms that we'll be using when we deal with magnetism part. Okay? First is intensity of magnetizing field. So, simply by giving definition, it is not necessary, you will understand. You have a magnet, right? North pole is here, south pole is here. Near to this particular magnet, I am keeping an iron nail. ये क्या होता है? Iron nail. So what you usually see while you do this in your real life, when you keep an iron nail next to a magnet, you know that the iron nail is getting attracted. Why? What is happening while you keep an iron nail near to a bar magnet? How many of you know? What happens is this iron nail will get magnetized. Matlab, this will be converted into another magnet where this pole will be converted as a south and this will be converted as a north pole here. And this north is attracting this south pole of the magnetized iron nail, and that is the reason iron nail is getting attracted to the magnet. ठीक है? Now let us explain what is intensity of magnetizing field. Intensity of magnetizing field, which is defined with the symbol H, is defined as the ability of the given magnet to magnetize the materials kept close to it. Right? How much ability a given magnet has to magnetize other material is simply defined as what? Intensity of magnetizing field H. Okay, so if H is given, we can find out the magnetic field produced by this particular bar magnet. How much will it be? B naught will be equal to mu naught into H. This is very important. What is it? The magnetic field produced by a given magnet is equal to mu naught times H. What is it? Intensity of magnetizing field. This is the relationship. It's very important. It's very, 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 very super important. Write it down. Okay. Another thing that I want to tell you is, if we are talking about a solenoid, because we all know that a current carrying solenoid will be acting exactly like a bar magnet, isn't it? So yes. So if we are talking about solenoid and its H value, the H value of a solenoid is given by the formula of N into I. I is the current. N matlab number of turns per unit length. N is total number of turns, L is total length. So capital N by capital L is small n. Okay, ये भी लिख ले. Is it done? Is it done? Okay, I hope everyone is noting down. All these are very important formulas. Okay, कोई बात नहीं माही. Please do watch the replay tomorrow. Okay. Then क्या? Next term what we have to learn is intensity of magnetization. What is it? Here we were talking about intensity of magnetizing field. Now we have intensity of magnetization, right? Intensity of magnetization. We either use a simple I, and in your physics NCERT textbook we have used a symbol of M. So either we can use either I or either capital M. What is it? Iron nail is a material which is getting magnetized, है ना? So intensity of magnetization is the ability of the material to undergo magnetization. मतलब here in our example, what is the ability of iron nail to undergo magnetization? If it can do large amount of magnetization inside it, M value will be larger. If it is lesser, it will be lesser. ठीक है? So ability of the material to undergo magnetization is what we define as intensity of magnetization. Okay, what are the formulas associated with it? Intensity of magnetization I is equal to total magnetic dipole moment. M is not pole strength. You can write it down. This is a magnetic, okay, dipole moment divided by volume. Okay, this equation is more important. You can learn it. So magnetic dipole moment divided by volume is defined as intensity of magnetization. Very, 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 very important. Okay. Next, you know that when the material get magnetized, it will be producing a magnetic field, BM, right? Okay. So the magnetic field produced inside the material BM is equal to mu naught times M. M is intensity of magnetization, which is I or whatever it is. ये भी note कर ले. What is BM? BM is the magnetic field induced inside that iron nail here. Here we have iron nail, है ना? So any general material, whatever is a magnetic field induced inside it, that is equal to BM. ठीक है? So BM is equal to mu naught times M. ये भी write कर ले everyone. Okay? Is it clear? So BM का value होता है mu naught times M, intensity of magnetization. Okay. प्यारी शिंजन की बात वो मेरा सेकंड प्यार हो बिग बॉय क्या हो रहा है इधर. Okay. Now this is producing, मतलब the magnet that you keep is producing a magnetic field of B naught, right? The material is getting magnetized to a value of Bm. So tell me, if you take a point here, what will be the total magnetic field? That will be the magnetic field produced by the magnet plus the magnetic field produced by the induced magnetic material, that is Bm. ठीक है? So total magnetic field B will be equal to, देख ले, B naught plus Bm. B naught क्या था? Mu naught H. Bm क्या था? Mu naught I or mu naught M, whatever intensity of magnetization. So you can write it as mu naught into H plus I. Okay, so the net value of magnetic field is equal to mu naught into H plus I. Next, so idhar tak write it down, remaining equations I'll tell you. Okay, this you don't have to give the answer now. Okay, now what is magnetic susceptibility? It is the ratio of magnetic susceptibility is the ratio of intensity of magnetization to the external magnetic field that you apply, or intensity of magnetic field. M by H का value होता है susceptibility. Okay, what is it? What is it? Susceptibility का value होता है M divided by H. What was M? Okay, the ability of the material to undergo magnetization, or you can say magnetic field produced inside the material. Okay, magnetic field inside the material. I'm writing it in short form. H is the magnetic field produced, what? Produced by the magnet. Produced by magnet, right? Okay, tell me, by using these two concepts, tell me, if X value is greater than 1, what does it mean? देख ले, look into the equation and tell me बच्चा लोग, if susceptibility value is greater than 1, मतलब क्या है कि M value is greater than H. इसका मतलब ये कि the magnetic field produced inside the material is greater than what? The external magnetic field that you apply. First thing, very important this is. Okay, if X is greater than 1. Okay, now if X ka value less than 1, which means if value of X is between 0 and 1, मतलब ये है कि okay, it's a ratio, susceptibility का value ratio होता है, right? A ratio between 0 and 1. इसका मतलब ये है कि M value is less than H, isn't it? Yes or no? If M value is lesser than H का मतलब क्या है? इसका मतलब ये कि the material which is undergoing magnetization is producing a lesser magnetic field compared to the external magnetic field, right? Hi Lakshmi, मैं तो बिल्कुल बढ़िया. Then if susceptibility is negative, susceptibility negative का मतलब क्या है? वो क्या? इसका मतलब ये कि the direction of M and H are different. Susceptibility is negative, मतलब the direction of M and H are opposite. So इसका मतलब क्या है? देख ले. So this is the magnet between north and south, and this is our iron, okay, or any material which is undergoing magnetization. So in that case where susceptibility is negative, what happens? Take it. This is having a magnetic dipole moment towards right. So this material which is undergoing magnetization, if the susceptibility is negative, it means the dipole moment produced inside the material will be opposite to that of what? To that of the external field or to the magnet. So this will be the direction of the magnetic dipole moment produced inside the material. Okay, if this is the direction, can you tell me what will be this end ray? Because it always starts, okay, which means the magnetic dipole moment always starts from the south and it will be moving towards the north. So you can see that if the material is having a susceptibility value negative, north and facing each other, so what happens? If north and north face each other, they repel each other, isn't it? Don't they repel each other? Yes or no? Nikita, thank you so much. Don't they repel each other? Yes. So if susceptibility is negative, right, the dipole moments are induced in the opposite directions. So the materials repel each other. Is it clear? Repulsion. Very good. Is it good? Okay. One last thing. Relative permeability, I hope you all know, right? What is relative permeability? Those who don't know, permeability of the material to permeability of free space. This is given as 1 plus susceptibility. Okay, the very last formula that you should be knowing. If you know all these equations, any equation that pop ups from this part, ऐसे कर सकता है. ठीक है? Back, good to have you back, Sanjana. So have you all written down the formulas? I'll take you back to all the formulas, starting with H value. Okay, H was also equal to Ni for a solenoid. Two important equations I have noted down and put in a bracket from the first page. Then intensity of magnetization, two formulas. Okay, फिर susceptibility का formula, total value of magnetic field का formula, right? And what happens according to different values of susceptibility inside the material. Is it clear? सबको? Everyone? Myara, Palak, Big Bro, Nikita, Sanchana, Anna. Everyone, jaldi bata dijiye. Is it clear to everyone in the classroom? Okay. Okay. बिल्कुल करेगा मेरा. Okay. Now, we are going to divide the entire materials into three, how it react to an external magnetic field. Shall we? Huh? We are going to divide the entire set of materials that is available in this universe into three according to how it behaves to an external magnetic field. Starting with the first set, bacha log, please note it down. All these are very important and this is your best chance, Anna, because I'm giving you only the important points. You can write it down. You can make your short notes from here. Right? It's an amazing opportunity, so make use of it, bacha log. Okay, देख ले. First one, what is a diamagnetic substances? Read the definition. वही है. These substances, when placed in an external magnetic field, acquire feeble magnetization. मतलब a small magnetic field is induced inside it in a direction opposite to that of the applied field. Okay, so the direction of a magnetic field induced inside the material is opposite to the external magnetic field. Such kind of materials are called as diamagnetic. We already have discussed what will be the value for such kind of materials. If the magnetic dipole moments or magnetic fields are in the opposite direction, what will happen between the materials? They will be repelling each other. Matlab, if diamagnetic material is kept near to another magnet, that will be repelled. Okay, this is very important. You can write it down. So this will be repelled in an external magnetic field. You can write it down. Okay, yes. Then the next thing what you can write down is the value of magnetic susceptibility. Susceptibility ka value will be between 0 and -1 because susceptibility will be negative because the induced magnetic field is opposite, and as the magnetic field is very less, the ratio will be between 0 and -1. Okay, then about relative permeability will be a value lesser than 1. So by looking into these two values, we can understand whether the given material is a diamagnetic substances. Note down kar le. And how it behaves. If a diamagnetic material is kept external to a magnet, right, which means if it is kept in external magnetic field, if you have diamagnetic substances hanging on a rope, right, this diamagnetic substance, as it is repelled from both the ends, it will be existing in the vertical direction. Okay, this also can come as a question for your exams. Bilkul, Sudeep. You can mark everything, right? Because exactly the flow of topics is exactly according to NCERT, because we are making the crash course for our NCERT, matlab, our term one examinations, right? So you can keep your. Okay, so today Menti will start by 10:45 or 10:50, I think. We can start early. The topic is not so hard. Okay, yes. Then what we have is paramagnetic substance. Okay, what is paramagnetic substance? Dekh, in a magnetic field, it acquires feeble magnet. Matlab, the magnetization induced inside the material is feeble, matlab chotu hai, and it's in the same direction as that of the external magnetic field. Matlab, the magnetic field induced inside the material and the magnetic field provided are in the same direction. This is another important thing. This is very important thing. Okay? And as both of them are in the same direction, what happens to a paramagnetic substance? Once you keep it in an external magnetic field, it will be attracted to the external magnetic field because they are induced in the same direction. Okay. What about susceptibility value? Susceptibility value will be between 0 and 1, and relative permeability will be value a bit greater than 1. So by looking into these two values, you can understand whether the given material is paramagnetic or not. Some examples of paramagnetic are given: platinum, aluminum, chromium, manganese and all. Okay, लिख लिया everyone? I hope you all have noted this down, right? All the points related to a paramagnetic substance. Yo? Yes. Very good, very good, very good. Next, what you can see is a paramagnetic substance, right? A material. How the atoms are arranged when no external field is applied, okay? And how the atoms are arranged when external magnetic field is applied. Okay. देख ले everyone. A paramagnetic substance, okay, if you consider each and every atom of a paramagnetic substance, ठीक है बच्चे लोग, each and every one has a magnetization or each and every one has a dipole moment. What did I say? Each and every atom of a given paramagnetic material will be having a dipole moment. The direction of dipole moment produced by each and every atom is what you can see here in the figure. Can you see बच्चा लोग? देख सकता है क्या आप लोगों को? Okay, can you see? Okay, so you can see that each atom is having a dipole moment, but they are in random direction. As they are in random direction and as there is no external electric field, if you add up the dipole moment in this case, it will be 0. Matlab, the net value of dipole moment in a paramagnetic substance when external magnetic field is no applied will be equal to 0. Okay, फिर क्या हो जाएगा? Once you apply an external magnetic field to this paramagnetic substances, the dipole moment of all the atoms will be aligned in the same direction as you can see. Can you see that? So it will be producing a net dipole moment from this end to the other end. Matlab, this end will be having the starting from where to where the dipole moment is directed, from south towards north. So this is how a material is converted as a magnet, because the dipole moment of all the atoms will be aligned in a particular direction, which will make one of the end as south and the other end as north. हो गया बच्चा लोग? So I hope you understood, right, how it works. Is it clear? Everyone, मेरा बच्चा लोग? How a paramagnetic substances are acting like a magnet in an external magnetic field. Done, done, done. Okay. Yes. Very good. Very good. Very good. Then Curie's law. What is said in Curie's law is like, you can see susceptibility, right? So Curie's law tells that the susceptibility of a given paramagnetic material is inversely proportional to temperature. Susceptibility means its ability to undergo magnetization, right? So as we increase the temperature, if temperature is increased, susceptibility decreases. मतलब क्या है? मतलब ये कि at higher temperature the paramagnetism will be showing less magnetization. This is what it says. Okay, as the temperature increases, the ability of a body to undergo magnetization will keep on decreasing. Okay, the actual formula, this is proportionality. Actual equation is C mu naught divided by T. Mu naught is a permeability, right, of a vacuum. T is the temperature in Kelvin scale, and C is Curie's constant. This is Curie's law. You already read this. Very good. बिल्कुल बढ़िया. Okay. Note किया regarding Curie's law. This is very important question. Can come from this part. So जा रहा है to the last set of material, which is ferromagnetic substances. Okay. So ferromagnetic substances क्या होता है? So till now we were talking about feebly magnetized materials. So those materials which are strongly magnetized, if you keep in an external magnetic field, वो होता है ferromagnetic substances. Obviously, the magnetization is in the same direction. Okay, and as the magnetization in the same direction, the ferromagnetic materials are strongly attracted. Okay, strongly attracted in an external magnetic field. ये भी लिख ले. Tune सारा मनसिलाई sir. Okay, yes. हाँ, very good. Magnetization of paramagnetic material is inversely proportional to absolute temperature. So they, yes, very good. Said the correct thing. Okay, yes. फिर क्या है? Now, regarding the relative permeability and susceptibility value. Susceptibility value of ferromagnetic substances are very much greater than 1, which tells it's a very good magnet. And relative permeability value is also very much greater than 1. Okay? You can note these two also. Now, देख ले. Curie's temperature, what it is, I am going to explain later. Okay, don't worry, I am just going to explain. देख ले. Now, what makes ferromagnetic substances different from paramagnetic substances inside the material? That's what we are going to learn. What is it? How ferromagnetic and paramagnetic substances are different from each other. Here also, each atom will be having a net dipole moment. So, net dipole moment of an atom is there. All the atoms which is having a dipole moment in a specific direction will be forming as a group. Can you see? All the atoms which is having a dipole moment in a particular direction are forming as a group. ये group का नाम क्या होता है? Okay, ये group होता है. ठीक है? Now, when external magnetic field is not given, right? All the groups will be forming different directions, and net dipole moment in the absence of an external magnetic field is 0. ठीक है? Nobody have told me what do you call this group as? The group of atoms which has a magnetic dipole moment in the same direction, you call it as domain. ठीक है? So you'll be having separate domains, one domain, two domains, three domains, which are randomly directed in different directions. And if you find out that net domain, matlab net magnetic dipole moment of the entire material, it will be 0 only. But once you keep this ferromagnetic material in near to an external magnetic field, what happens? The magnetic dipole moment of all the domains will be in a particular direction according to the external magnetic field. Can you see that? These all were randomly directed. Now, according to the external magnetic field, everything will be aligned in a specific direction. ठीक है? Every atom's magnetic dipole moment will be aligned in a specific direction. समझ में आ गया सबको? Everything will be in a specific direction, which make the ferromagnetic materials as a magnetic materials here. Very good, Sana. Very good. I hope you all are noting this down. Okay, so the presence of domain is the only difference the ferromagnetic substances are having from the paramagnetic, and that's what the presence of this domain is making the ferromagnetic material a stronger magnet compared to paramagnetic. Okay, hi Amit, late to the class. क्या हो गया? Now here in the case of ferromagnetic substances also, if you increase the temperature, what happens? Its magnetization property decreases, right? So if you keep on increasing the temperature of a ferromagnetic substance, its magnetization decreases. At a point, the ferromagnetic material will be converted into a less strength wala magnet, which we call it as paramagnetic material. The temperature at that point is called as Curie temperature. Okay? The value of temperature at which a ferromagnetic material is converted into paramagnetic material for the first time, we call it as Curie's temperature. Very important. Okay, it's very important, super important. Hi Vijayashree. So, bye math loving boy. सोने के लिए जा रहा है. Very good, Ruli Devi Prajapati, right? Okay, very good. Noted? Good. Now, here we have the questions. जल्दी बता दे बच्चा, जल्दी बता दे इसका आंसर क्या होता है. डन डनाडन सुदीप, बिल्कुल बढ़िया. नोटेड. आंसर किसको पास भी नहीं है क्या उत्तर इसका? I was explaining each and every concept step by step so that everybody can understand. Now when I ask you the question, nobody has. Answer, is it B? Sana is like Urubakshe B. Wow. देख ले चलो. An example of a perfect diamagnet is a superconductor, right? This implies that a superconductor is put in an external magnetic field of intensity. The magnetic field Bs inside the superconductor. Bs is a magnetic field inside the diamagnetic material. B is the external magnetic field. What did I tell you while we were discussing this? A small feeble magnetic field is produced inside the material. So the value of Bs is a feeble value, मतलब a lesser value compared to the external magnetic field, isn't it? And the value of Bs will always be opposite to it. It cannot be equal. Okay, it cannot be equal to 0 also. A small magnetic field is produced here, right? But it has to be a value lesser than the external magnetic field, right? Ha, Vijay Shri, very good. It's option C. Okay, just be in the classroom, just go along with the flow, and if you have any doubts, let me know in the chat box, Amit. That's all you want to do, just like you do in all the classes. So, समझ में आ गया? हमारा option D मिल गया हमको. Okay, so correct option is D. Is it clear? Okay, did I say C? Okay, I meant D. Okay, actually I have cancelled A, B, and C, as you know. हमारा option D है. Did I say D? Sorry, C. So हमारा correct option D है. Okay बच्चा लोग, it's option D. Yes, got it. Okay, बिल्कुल बढ़िया. Someone is asking T and TC क्या है? अरे T is the temperature of a body at any point of time. TC is Curie's temperature. That temperature at which a ferromagnet is converted itself into a paramagnetic material. Okay. Another question. Sorry, not question, another concept. Anna, this is very important of what is hysteresis curve. देख ले, everyone listen. It's very important. Now, H is the external magnetic field that you apply, right? Intensity of magnetizing field, and B is the total magnetic field produced inside the material. Okay. देख ले, we are starting from the 0 point. If you increase the value of external field, obviously the field inside the material will also increase. right? So H increase, B increase, H increase, B increase, H increase, B increase till it reaches a maximum saturated value. After this point, even if you increase the external field, the internal field is not going to increase. It is going to, or it has reached the maximum value. Okay. Okay. So this is going to be the graph from 0 to, if you keep on increasing the external field, the magnetic field internally will also increase and reaches a saturation value. Okay. Then, so for perfect diamagnet, would field lines enter the supermagnet? No, it won't enter, right? That's how we define as a superconductors, which means the perfect diamagnetic material. Okay, देख ले. Class 11th happens at what time? Class 11th happens at 8 p.m. है ना आयुषी? Okay, so Miara is helping me out. Thank you so much, Miara. देख ले. Now, tell me what happens to the magnetic field inside the material B if external field is decreased. मतलब external field decrease कर रहा है मैं. So obviously the magnetic field inside the material also decrease. But you can see that it is taking a different path, है ना? It is not coming back according to the same path through which it has moved up. It is not taking the path of OA. It is now moving or taking a different path, and it is moving like this. H decrease, B decrease, and when H becomes 0, this is the point to where the graph has reached. Okay, so can you tell me what this magnetic field you call it? Even when the external field is 0, there remains some magnetic field inside the material. This magnetic field, we call it as retentivity. The complete definition is given here. You can just read it. The retentivity of a substance is a measure of the magnetization remaining in the substance when magnetizing field is removed. Even when the external field is removed, whatever is the magnetic field existing in a given material, we call it as retentivity. हो गया? हो गया? Yes. Next, to this material which is having a magnetic field of this much value, what you are doing? You are giving an H value, matlab external field value in the opposite direction. देख ले. Now you are taking the H to negative direction, matlab you are providing external field in the opposite direction. What happens? The magnetic field of the material decreases. At a point, magnetic field induced inside the material becomes 0. So this value of external magnetic field, which can make the magnetic field of the material 0, we call it as cohesivity. If you want the definition, read kar le. Cohesivity of a substance is a measure of the reverse magnetizing field required to destroy the residual magnetism. So whatever was a magnetic field remaining inside the material, if you want to cancel it, how much external field has to be provided in the opposite direction, वो होता है cohesivity. Is it clear? Is it clear what is cohesivity? Okay, this much value of H is cohesivity. This much value of magnetic field remaining is retentivity. Very important. Okay, and the area of this loop will give you the energy loss. Area of this loop है ना बच्चा लोग, it will give you the energy loss. ये भी लिख ले. Okay, we are almost at the end of this particular session. Almost by 11 we can start the Menti, I think. Okay, so H and every values we have defined. Now we can go for questions. Now we can go for the questions, बच्चा लोग. कर ले. Everyone, do the prompt. Read the question. Give me the answer in the chat box and let me see. Jaldi. Arey, it's a very simple question. Obviously from this particular part we cannot ask you any hard question, so obviously it's a simple chotu question. अमित राणा बोल रहा है कि ऑप्शन सी है सर. संजना बोल रहा है कि बी. Then last 5 seconds to answer. उसके बाद I'll start answering. Rolly is like option C. Okay, 4, 3, 2, 1. Now, for a diamagnetic material, we have to choose a value for susceptibility and relative permeability. How many of you do remember? No. Option B is with a negative X. Option C is with positive X. Susceptibility value. देख ले, for a diamagnetic material, susceptibility value should be between 0 and -1. And relative permeability value should be lesser than 1. Which among the 4 options satisfy this? Susceptibility value between 0 and -1? Option B, minus 0.5. Mu r 0.5, which is lesser than 1? Yes, that also is being satisfied. So हमारा उत्तर क्या है? अरे बच्चा लोग, हमारा करेक्ट उत्तर क्या है? ऑप्शन बी. मिल गया तो मिल गया, आंसर मिल गया. अब समझ में आ गया है ना? अंडरस्टूड व्हाट द डिफरेंस बिटवीन ऑप्शन बी एंड सी. छोटा मिस, स्मॉल चेंजेस देयर, नेगेटिव का. ओके, वेरी गुड शुभम, इट्स ऑप्शन बी. हाँ हाँ हाँ, ठीक है, कोई बात नहीं, कोई बात नहीं. So the concept is clear, I suppose. Moving on. Hysteresis loop for magnetic materials A and B are given below. These materials are used to make magnets for electric generators, transformers, and electromagnet core. Then it is proper to use. Which one? We have two magnets, right? So the hysteresis loop with the first magnet is given as A, right? For the second material is given as B. So which material, whether the material A and B, can be used for electric generators, transformer core, and electromagnet? I think we will do this question, है ना बच्चा लोग? ये 3 question है ना? We'll be doing it after this particular concept. Okay. First I'll explain this, then we'll go back to that particular question. Because I thought that this concept is explained without explaining this concept, you won't be able to do that problem. ठीक है. Magnets divided into 2. Okay, we have magnets now. Not the materials we are classifying into dia, ferro, and para. We are classifying the magnets into 2. Okay, which are the 2 kinds of magnet? One is permanent magnets. Permanent magnets क्या होता है? Those materials which will be acting as a magnet for a large interval of time. Those are called as permanent magnets. Okay, so what should be a permanent magnet? Even if there is zero external field, right, there should be a large value of magnetic field. Matlab, it should be having a very high retentivity, right? The value of cohesivity should also be so high so that small minor external magnetic field cannot erase the magnetic field inside the permanent magnets. So if a material should be acting as a permanent magnet, it should be having very high retentivity and very high cohesivity. Okay, just learn this as such. For permanent magnets, high retentivity and high cohesivity should be there. So the best example is steel can be used as a permanent magnet, right? Cobalt steel, okay, alnico, all these can be used as materials to make permanent magnets. Is it clear? Bacha log, regarding permanent magnets. Okay, yes. Next is what we have is called as temporary magnets. ठीक है, temporary magnets क्या होता है? Right, those magnets where magnetism exists for a short interval of time. right? If magnetism is existing for a short interval of time or according to what we need, we call it as a what? Temporary magnets. ठीक है. One best example for a temporary magnet है ना बच्चा लोग, वो इलेक्ट्रोमैग्नेट होता है. One best example for temporary magnet is electromagnet. Do you know what is electromagnet? Okay, do you know what is the electromagnet? It's a solenoid. Can you see the solenoid? Which is a wound or an soft iron core. What will happen? If a solenoid is wound around a soft iron core, what will happen? It's very simple. If a current is passing through a solenoid, we know that magnetic field is being produced, mu naught Ni. This magnetic field produced by the solenoid will magnetize this soft iron core. So the magnetic field will also be produced by this soft iron core, Bm. So the total magnetic field will be equal to B naught plus Bm. So if you are having a solenoid wound around a softened iron core, what happens? A large value of magnetic field will be produced whenever there is current in the circuit. Because you can see that only current is there, magnetic field is there. So once you remove the current, right, magnetism will be gone. Once you give the current, it will be acting as a magnet. Isn't this our temporary magnets? है ना? So this one example for a temporary magnet is electromagnet. When current pass हो जाएगा, it will be acting as a magnet. When current is removed, current तो नहीं हो जाएगा. Okay, clear? Okay. So for the material to be acting like an electromagnet, right, or a temporary magnet, it should be having low, okay, it should be having a very low value of retentivity, okay, and very low value of cohesivity, right, which means no magnetism should be retained inside the material when external magnetic field is not there. Okay, it should be gone away. High permeability should be there. What do you mean by permeability? Permeability means ability of a material to undergo magnetization. Obviously, the material should be having ability to undergo magnetization. So high permeability should be there and low hysteresis loss. Matlab energy loss should be less here. Is it clear? Is it clear, bachcha log? Is it clear? Yes. Okay. So the places where electromagnets are used, you can see electric bell, transformers. So in transformers, electromagnets are used. So extracting bullets, right? For all these purposes, we use electromagnets. Crystal clear? Please note it down. So there we come and end to the theoretical part. One question we'll do from here and the remaining questions are Menti. So in 2-3 minutes, we are going to start with our Menti. Mera bachcha log. So Sana, Pinalla, Sudeep, yes, crystal clear. So give me the answer for this also. So generators, in generator है ना बच्चा लोग, will be using permanent magnet. Those who don't know, I think I haven't defined this. Right? In generators, we'll be using permanent magnets. Okay? So ये भी note कर लें. This is very important. And in transformers and electromagnet, we already have defined what we'll be using. Temporary magnets. So based on this particular information, you can look into the options and give me the answer. Jaldi. Bacha log, waiting for your answers. Everyone. संजना बोल रहा कि मे भी है. Amit is like A. D lock किया Sudeep. Sudeep is like I fixed the answer. राइट। हना बोल रहा है कि सी है। ओके, सो कोई बात नहीं, देखेगा। लेट्स सी, फॉर जनरेटर्स it should be a permanent magnet, and for permanent magnet we know that retentivity and cohesivity should be large enough, right? Yes or no, we have to find. So in which material, whether the material A or B has a large retentivity and cohesivity? Obviously A. So we can say that generators are made with the help of material A. What about temporary magnets? It should be having low cohesivity and retentivity, है ना? So it is a graph B which shows low retentivity and low cohesivity, है ना? So we can say that the material B can be used for transformers, okay, and for electromagnets. ठीक है? Now choose the option. आप ही choose करना है, choose कर ले. A for transformers, it's wrong, right? B for transformers. A for electric generators, correct है, and transformers, no, A is only for generators. B for electromagnets, yes, and transformers, yes, बिल्कुल correct है. B is for transformers and electromagnets, बिल्कुल कही. समझ में आ गया? A for electromagnets, wrong. B for electromagnets, right? Hey, समझ में आ गया बच्चा लोग? बोल ले. These are very good conceptual question, let's say. Is it clear? Is it clear मेरा बच्चा लोग? जल्दी बोल. Oh sir, D तो wrong है ना? A for electromagnets, no, B is for electromagnets. देख ले, I have clearly written. Okay, yes, yes, yes. क्या हो गया मेरा? What happens? I'll watch a recap. What happens? There's some concept not clear. Clear? Very good, very good. Okay. So, shall we proceed? Okay. So, what do we have? That exciting part of the session, right? The last part of this particular chapter. We are going to do Menti from this particular chapter. And here we are at the end of this chapter. Jaldi. Menti code is given. It's 519888. And those who join the Menti, jaldi, tell me what your avatar is. Jaldi, 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 मेरे बच्चा लोग. Go and log into Menti and tell me what your avatar is. Vijayashri, Menti. Okay, Nasrin is like so fast today. Yes. So, yes. So I think we started a 15 minutes early, है ना Menti? As I have told you, chapter तो छोटू है. So बिल्कुल. So, Miara avatar is a lollipop. Okay, good. So I'm gonna switch to our Menti wala window. So those who have joined can update me what your avatar is. Jaldi, फटाफट कर ले. Code I hope you all can see on the top. Amit, tiger baby है. Tiger baby कहाँ है? Array, it's a big tiger only. The picture is small. That's the only only thing. It's not a baby. So can you all see the code, bachcha log? On the top you have 519888. Sanjana rabbit है. अरे rabbit looks so funny है ना. देख लो उसका दांत कितना whitish है. Rabbit itself will be thinking मेरा दांत इतना सफेद कैसे हो गया? Sudeep was like flag कहाँ है इधर? I can't see a flag. Oh, okay, this one है ना? Okay, this one is a flag. Okay, ठीक है. हाँ, बिल्कुल सना. Okay, we'll put the BGM. Wait for it. So I think those who want to join have joined, right? बच्चा लोग join किया ना? We'll have 5 questions like we do all the time, and yes, we'll start the Quiz in 5, 4, 3, 2, 1. Here we go. The very first question. Okay, I think अरे बाप रे कितना छोटू question दे दिया. The material suitable for making electromagnets should have. Material suitable for making electromagnets should be having what and what. मतलब what should be their retentivity and cohesivity value. Answer. I think everybody should have been answered by this time. It should be having very low retentivity and very low cohesivity, है ना? Which means option B होना चाहिए. Just now I have told you, isn't it? Just now I have told you, है ना? हाँ, Nesrin already have given the answer B. Then others. Okay, so don't compare while you think about the soft iron, right? Soft iron, we use it for making electromagnets, right? I know that everyone is thinking on that basis because for soft iron, the retentivity is high, okay, cohesivity is less. The reason why we use soft iron for making electromagnet is because we are not getting a suitable material for making the electromagnets. समझ में आ गया? Because for making a suitable electromagnet for a perfect electromagnet, right, that material should be having the low retentivity and the cohesivity. समझ में आ गया? Obviously, we are using, once again, we are using soft iron as electromagnets. It has having a high retentivity and low cohesivity value because we are not getting a material which is having low retentivity and low cohesivity at the same time. समझ में आ गया सबको? Somebody asked me the doubt. में आ रहा है? Is it clear? जल्दी बोलते, जल्दी बोलते, जल्दी 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 जल्दी. कंफ्यूजन तो कंफ्यूजन, सॉल्यूशन तो पता नहीं. Okay, this is it. Just listen to it. What I have said right now once again, right? You will understand. कुरूप आड़ी बड़ी मूवी. ये कौन है? हाँ, I think it is Sana only, right? सना ही हो सकता है. Okay, so we are proceeding further for the next one. Okay, so we're gonna start. Sudeep, it's you. Okay. Good, good, good. So needles N1, N2 and N3 are made up of ferro, para and diamagnetic substances. A magnet when brought close to them. Okay, when you are bringing an external magnet close to ferro, para and diamagnetic material, how they are going to act? Very simple. Very simple, right? Answer 25 seconds, बच्चा लोग. Last 14, 13, 12. हाँ हाँ बिल्कुल सना. It's a good movie है ना? I watched this Saturday. Very good, very good. देख ले. N1 is a ferromagnetic material, right? Okay, ferromagnetic materials are strongly attracted to magnet, so attract N1 strongly. Paramagnetic materials attraction but weakly. देख ले in the option B N2 weakly. N3 मतलब diamagnetic substances. Diamagnetic substances are always repelled in an external magnetic field. So repel N3 weakly in the second option. Okay. Amit, my luck is very dull today. अरे luck की बात नहीं है. Just learn the concept. उत्तर ऐसे आ जाएगा. Okay. Now everybody is behind Dulquer Salman and the movie Kurup, है ना? Everybody come back. We have 3 more questions and I am going to leave you. Okay. Yes. Next. What do we have here in the chat box? So ये दुलकर सलमान कौन है? Oh, that's the reason. कोई बात नहीं, Amit. Happens sometimes, right? Okay. Next time you are gonna make up huge performance. So Kurab, Sudeep है ना? So Sudeep is on the top. Then we have Shraddha, the fastest person to give the answer this time. Purishan and Anigreh के नाम. ये तो बिल्कुल सना ही है. Dulquer Salman, I think it's Sana, right? Then we have Amit, Lokik, Ved, Hi-Fi sir, proud of Ameer sir, Sanjana, Priya. Jaldi everyone, make me also proud, Sanjana. Give the answers. छोटू छोटू क्वेश्चन चल रहा है ना? Okay. So yes, moving for the third question. If you all are ready, shall we? I think everybody is here, ready? Okay, Dulquer Salman is Miara, right? She has used same thing in the 11th standard class also at 8 p.m. So yes. You're multi-talent, right? Right, Sana? That's why everyone is behind you. That's the thing. Manveer, hi, Manveer. उत्तर दे दे. ये तो थोड़ा, it's a bit complicated compared to all the questions we did. है ना? Because all the questions we did were like ये choose करना है, वो choose करना है, okay ठीक है, ये choose करेगा, ऐसा वाला question था. So ये थोड़ा difficult है compared to all the other one, but still. Last 30 seconds बचा लो. 25. Last 20. जल्दी जल्दी जल्दी. Okay. Answer? Nobody? Everybody has voted. I have क्या हो गया? Mendy stuck हो गया क्या? Mendy is like confused हो गया. Mendy is also confused with this particular question. So Mendy is also not able to decide what's the correct answer. கொஞ்சம் brain, हाँ, brain तो use करना ही पड़ेगा. This person, Shraddha is the fastest this time also. So yes, Sudeep on the top, Shraddha second, then Myara, then Purushu, है ना? So this is the order. Okay, so I'll explain. Okay, ये थोड़ा explain करने का ही बात है. The midpoints of two small magnetic dipoles of length d, okay, which means that the length of the magnetic dipoles are given d, are separated by a distance of x. These two magnetic dipoles are separated by a distance of x. Okay. The force between them is proportional to x raised to minus n. What is the value of this particular n is a question. Is it 1, 2, 3 or 4? So you need to find out what is the relationship of force with respect to x. Do we have any direct formula? Is there any direct formula for finding out the force that is existing between magnetic dipoles? No. But how many of you know this particular, okay, how many of you know this particular equation for force? Force is equal to negative of du by dx from the chapter 11 standard, more precisely chapter work per energy. Differential of potential energy with respect to x is force. What is it? Differential of potential energy with respect to x is force. How many of you know this? Okay, those who don't know or those who have forgot this particular equation from 11th standard, write it down abhi ke abhi. Okay, jaldi likh liya. Okay, now dekh le. Now how we are going to proceed with this? Consider this as a magnet 1. Okay, this is a magnet 2. Tell me, is a magnet 1 is going to produce a magnetic field at the point where the second magnet is kept? Is it going to? Obviously, because the second magnet is kept on the axis of the first magnet. first magnet produces a magnetic field on its axial point. Formula क्या? Formula for magnetic field produced by the first magnetic dipole on its axial point. Mu naught by 4 pi. And now chalo, mu naught divided by 4 pi. Then 2m divided by x cube. Right? This is the magnetic field produced by the first magnet in the region of a second. Same is a magnetic field produced by second magnet in the region of first magnet. Magnetic field ka formula same hai. Okay, so we are not writing it separately. So a magnetic field is produced this much. You also know, if a magnetic dipole is kept in an external magnetic field of B, a potential energy is associated with it. Formula minus mb cos theta, isn't it? Yes or no? देख ले, minus m, b का वैल्यू कितना? Mu naught by 2 pi, 2m by x cube, right? And what is the value of theta here? This is from south to north. Magnetic dipole moment is in this direction. This is also from south to north. Right? So theta value you can take it as 180 degree. Right? You can take it as 180 degree here. So theta 180 hota hai. Okay, so cos 180 minus 1. So the only thing that you have to note down from here is u is inversely proportional to x cube. Can you see this? The value of potential energy is equal to 1 by x cube. So f का value कितना होता है? Minus du by dx. So removing all the constant terms from there, this will be negative d by dx of u is proportional to 1 by x cube. Okay? Yes. Next, 1 by x cube differential. How will you do it? X cube is x raised to minus 3. Differentiating x raised to minus 3 कितना मिल जाएगा? Minus 3 x raised to minus 4. Okay, so the value of f is proportional to, right, minus 3 x raised to minus 4. Here it is given that force is proportional to x raised to minus 8. Comparing these two, what will you get? n का value कितना मिल जाएगा आप लोगों को? 4. Okay. Yes. Is it clear? Don't have to go with theta value, 180 value. You just don't have to think about all those stuff, right? You just want to think about this. Matlab, force is equal to negative differential of potential energy with respect to x. First thing, right? Value of magnetic field, value of potential energy, how potential energy is related to x cube. Differentiating that x cube with respect to x, how much answer it is going to give you. If you have understood this, answer is in your hand and the option is option D. अब समझ में आ गया? Okay, we just have taken u is proportional to 1 by x cube because remaining terms are constant, which is not going to affect our answer. So we have not considered all those. Okay. Okay, so understood. Is it clear? चलो clear है क्या? Okay. Yes. So someone was asking how it is 180, right? So obviously you should be knowing how it comes as 180. It's a very good legit question and a doubt, है ना? So obviously we have time and explain. देखिए, this is north and south, है ना? Okay, so this is north and south. So you can see that this will be producing a magnetic field, I say. Okay, so the direction of magnetic field is ऐसे, मतलब ऐसे आ जाएगा, that is towards left, and the dipole moment is also towards left. Okay, 180 नहीं आ जाएगा, 0 आ जाएगा, चलो 0 आ जाएगा. So I'll take it a fresh page and make you understand. Take it. South, north, है ना? South, north. This magnet is having a dipole moment in this particular direction. So we'll mark M is in this particular direction. What about the direction of magnetic field produced by the other? it is from south to north ऐसे, है ना? Okay, north to south ऐसे जाएगा magnetic field. So the direction of magnetic field produced is in towards left direction. Magnetic dipole moment is also in that direction. So theta कितना हो जाएगा? 0 हो जाएगा. Right? समझ में आ गया? Okay. Happy smile everyone. Let me see that happy smile. Yo, yes, got it. Okay, so let's move on to our fourth question, bacha log. Okay, so let's see how tough is our fourth question. Okay, so I'm going to press the enter key, which will show us the fourth question, and let's see what do we have here. A bar magnet is demagnetized by inserting it inside a solenoid of length 0.2 meter, 100 turns, and carrying a current of 5.2 ampere. Right? So the cohesivity of bar magnet. कर ले ये? It's a very simple question. Cohesivity का formula, H का formula, I hope you do all remember for a solenoid. Jaldi. Option A, B, C, D we have. Which one? Very good. So you do all remember the formula for cohesivity, right? So record completed in 9.99 seconds. Good. Many of you got it correct, right? Shraddha again, the fastest person, then Kurup on the top, Dulkar on the third, Purushu on the fourth, Lokik, Proud, Sanjana, then Ved, Amit, Priya, and Gamer, right? अरे देख लिए simple question. मतलब cohesivity मतलब क्या है? It is a value of H which can delete or remove the magnetism from a given bar magnet, right? The value of H होता है. H का value कितना? Ni, isn't it? N is number of turns per unit length. Number of turns per unit length. So total number of turns by total length 0.2 into I is 5.2. Isn't it? Yes. So ये कितना हो जाएगा? 100 by 0.2, 5.2. So 52 divided by 2. That is 26. Right? So this हो गया 2600. Answer B मिल जाएगा. कितना सिंपल है. I hope you understood, Anna. I hope you all know what is cohesivity. Cohesivity मतलब the value of H which can erase the magnetism from the paramagnet. Okay, and the value of H I already have told you, it's Ni. Done. आसान है ना? अरे बाप रे. Everybody is learning Hindi nowadays. Okay, here comes the last question, मेरा बच्चा लोग. The last question of today's session. Okay, same concept, same formula, but the thing that we want to find out is only different. That's the only difference here. Rest of the things are same. Done. Simple question है ना? Isn't it simple? Simple dimple. Okay, last 7, 6, 5, 4, 3, 2, 1, and time is up. And here comes the final winner of today's class. I think it's mostly Kurupana. I think Sudeep, right? Very good, Sudeep. Very good, very good. Keep it up. Then Shraddha, Dulkar, then Purushu, Ashwini, Log, proud of me, Sanchana, then Ved. Very good. Everyone did an amazing job. Okay. So, I hope you all have enjoyed the session, मेरा बच्चा लोग. All the concepts that we have discussed, everything, I hope you all have enjoyed. कोई doubt है तो बता दे. If you have any doubts, please let me know. Or if everything is fine, let us discuss this very last question. And okay, देख ले. बच्चा लोग. Very good, Sudeep, and to everyone who attended this particular quiz session and understood all the concept, बहुत बढ़िया. देख ले. The BH curve, मतलब hysteresis curve for a ferromagnet is shown here. The ferromagnet is placed inside a solenoid with 1000 turns per centimeter. मतलब n का value है 1000 per centimeter is 10 power minus 2 meters. Okay, ये कितना होता है 10 power 5 turns per meter. Converted centimeter to meter. वो ही कर लिया. The current should be passed in the solenoid to magnetize the ferromagnet. To magnetize, so not to magnetize, to demagnetize a given material, the amount of H has to be provided. We call it as cohesivity. ठीक है? Now, cohesivity value, H का formula क्या होता है? Ni. ये भी पता है. Now, for demagnetizing the ferromagnet, the amount of cohesivity that we have to apply, it's given how much? 100. Right? Okay. So this is equal to Ni. N kitna? 10 power 5 into I. So it is this particular current which we need to find out. So that is this, while you cancel under and 10 power 5, 10 power 3 remains on the left hand side. When it comes to the left hand side of the equation, this is 10 power minus 3. So I equal to 10 power minus 3 ampere or 1 milliampere hota hai. Okay. Very good, very good, very good. So everyone did an amazing job. So tell me, are the concepts from this particular chapter clear? Right? We try to discuss as many concepts as possible and all the questions from here. Yep. With a smiling face. Tell me, yes sir, बिल्कुल समझ में आ गया with a smiling face. You? Super duper clear. Amit, क्या हो गया? अरे don't worry, everything is fine. Maybe just like you said, a bad day for you. Because you are super, है ना? Nothing can defeat you. So yes, those who haven't liked the session till now, jaldi you can like the session and do let me know that you are enjoying the sessions. ठीक है? फटाफट बोल दीजिए मेरा बच्चा लोग. You can, those who haven't liked, जल्दी like करके बोल दे, sir, it was an amazing session. Okay, and tomorrow, let me tell you, at 4:30 p.m. we are having a special class. So it's an multiple choice question series in the form of quiz, where we have taken the multiple choice question from all the chapters which is going to come for term 1. So obviously, right, obviously it is going to be what a helpful thing to make a quick revision from all the chapters. So make sure that you are going to enroll for this. Those who don't know how to enroll for special classes, what you have to do, download the Unacademy learning app. ठीक है? फिर after downloading the Unacademy learning app, log in कर ले. After log in करने के बाद go to the menu. Okay, from the menu go to special. Okay, from the pop-up menu click on special. Right, after special है ना, so after clicking on special, what do you have to do? Type in the code AMB10. Once you type in this code, you will be getting this particular special class which you can enroll completely for free. Okay, yes. So clear. Malayalam song. You all need Malayalam song or what? You all need Malayalam song? हिंदी सॉन्ग चाहिए, मलयालम सॉन्ग चाहिए. Okay. Which one? Someone is like English. So I haven't sang any Malayalam song in the classes. One Malayalam song I know, so I'll just try to sing that. I'm not so good in it. So dekh le. If it goes bad, don't make fun of me, okay? തിരകൾ അലതല്ലുന്നിടനെഞ്ചിൻ കൂടിൽ തേനായി സ്നേഹം തേൻവരിക്കയായി പൂവായി സ്നേഹം പൂമ്പാറ്റയായി നിന്റെ കടുങ്കാപ്പിൽ നീയൊന്നു കാണാൻ ഞാനും ആ കടലിന്റെ കടവത്തു കാത്തു പറയാതെ പറയുന്ന കടുങ്കാപ്പി നീയുള്ള കരളേ നിൻ കനിവുണ്ടൻ കണ്ണിൽ കടും നിറമുള്ളേൻ കനിവുള്ളേൻ നെഞ്ചിൽ. Okay. Yes. So it's like I think it's an album song. It's like Kadungapi. Okay. Thank you so much, Divya, Ritu, Anna, then Sudeep, everyone. Thank you so much. Amit, next class, will it be fine? Will it be fine for next class? Okay. So next class, obviously, one Hindi song. Are Ameer Sana Summa. Are baap re. One last song, ठीक है? I know that. दो दिल मिल रहे हैं, दो दिल मिल रहे हैं, मगर चुपके चुपके, दो दिल मिल रहे हैं, मगर चुपके चुपके, सबको हो रही है, सबको हो रही है खबर, चुपके चुपके, दो दिल मिल रही है। Okay. So, thank you so much, everyone. I hope you all like it. So, just because Amit and some people told me to sing a Hindi song, so my throat was really bad. I tried to pull some energy from myself and thoda gaya. Okay, I made a small song for every one of you. So, Ritu, Anna, thank you so much. Okay, so I don't want to make sleepless nights for your family. Okay, thank you, Sudeep. अरे तू अवार्ड भी बना दिया. So ठीक है. So make sure that everybody comes for tomorrow's class, because for tomorrow's class mainly we'll be focusing on Menti quiz and multiple choice questions. Less will be the theoretical part, which means only we'll be going through the important formulas. ठीक है. 15 minutes formulas, remaining 1.5 hours we'll be doing Menti quiz and multiple choice question ka revision, which means tomorrow it will be Menti session. So make sure that everybody attends. Take your friends also, right? We should be having a very large crowd tomorrow. Take everyone, right? Make the class, let's make the class tomorrow awesome, right? Just like the song it is, just like you're telling it's amazing. If it's amazing, let's make the class also amazing. है ना कल? So tomorrow it's EMI. So share the class with every one of you, to all your friends, to everyone in the classroom. Take everyone to the class. ठीक है कल? These are the batches which is going to start. So thank you so much everyone. अरे हिंदी मुझे पता नहीं है ना. I'm not so good in Hindi, and obviously I want to make the explanation in English. Right. So good night everyone. Divya, Anna, Miara, Sudeep, Ritu, Anisha. Very good, Anisha. Happy to know that. Right. Okay. So thank you so much everyone. Those who haven't liked the session, है ना गाना गाया ना, so you can like the session right now. Okay. Then those who haven't subscribed, make the subscription to the channel. Then I think it's time to say good night and bye bye, and see you all in the next class. Bye bye everyone. See you all in the next class. Take